Anyone, please? What type of equation is it?
Exponential.
So an exponential equation is like 2 to the x, where the exponent is the variable. So this is exponential. Where it has a base, which is a number, and the exponent is the variable. The exponent is 2. The exponent is not the variable. So we've seen these equations before, last week.
Linear.
It cannot be linear because a linear equation has to have a power on the variable 1.
Radical.
Very good. A radical equation has to have a radical. If it does not have a radical, it's not a radical equation.
Quadratic.
Thank you very much. Quadratic. It's a polynomial equation, degree 2, quadratic. Good. So how many solutions do I have to write? For sure, always, when I solve a quadratic.
2.
2. Very good. We want to take square roots from both sides. So I'm going to apply the square root and apply the square root. Can anyone give us the solutions?
Let me plus or minus 2.
Thank you. This is it. Now we will continue with the second one. So we have x squared equals negative 3/2. I apply the same procedure, and then I'll say, oops. Why am I saying oops on this one and not on this one?
It's negative.
Yes, and we cannot take the square root from a negative number and obtain real solutions. This equation has x equals plus or minus I, the square root of 3/2. What is this? We're going to review this again today. So the square root of, let's say simply, negative 3 is the same thing with the square root of negative 1 times the square root of 3. And this is called the imaginary unit, I. So we do not need to continue here because the problem was simply asking us to find the real solutions, which we did. Okay. Do we need to work on another problem with substitution? Yes or no?
Yes, please.
Okay, do I get to choose? Do you want to choose? Okay, so we have 2 problems on the handout and you choose. I let you choose. I'm going to write both of them. So we have 3, 1 minus x, everything squared, plus 5, 1 minus x, plus 2 equals 0. And the last one here is x plus the square root of x minus 20 equals 0. And I let you choose. Or both. It's up to you. Let's make a decision.
First one.
The first one. Very good. So notice that this is again a simple situation. As long as I notice that this can be replaced by y, and this can be replaced by anyone. Otherwise, it's not quadratic in form, and I cannot use the method of substitution.
Y squared.
Excellent. Thank you. So we have 3y squared plus 5y plus 2 equals 0. So can we go through the whole steps again, over and over, over and over? Where's my handout? Descending order, yes. Greatest common factor, none. Negative leading coefficient, no. Binomial, no. Trinomial, no, 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 yes. So I need 2 numbers whose product is and whose sum is. I know by now you're getting tired of this. So what is the sum? What is the product? Anyone, please.
The product is 6,
Yes, indeed. 3 times 2. Awesome.
and then the sum is 5.
Excellent. Therefore, we need
3 and 2.
very good. So then this is 3y squared plus 3y plus 2y plus 2 equals 0. From the first two we factor out. So now by now everything should be a routine. We factor out what?
3y.
Excellent. And what is left?
Y plus 1.
Excellent. What do I need here? Guaranteed?
Y plus 1.
Indeed. I write it first just because I don't want to make an error. And now I look. Sign and factor. Sign.
Positive 2.
Excellent. What comes out? What is the common factor now here and here?
Y plus 1.
And what is left in parentheses?
3y plus 2.
Can anyone give us the two y's?
Negative 1 and negative 2/3.
Excellent. Is this good? It's brilliant, but not good enough. How come? 1 minus x. 1 minus x equals negative 1. And 1 minus x equals negative 2/3. The problem is asking us to solve for x, not for y. Y was our little baby. We used it to help us. We created this little baby. What baby? Y. Y is 1 minus x. So if y is 1 minus x, then 1 minus x can be negative 1. If y is y minus x, then 1 minus x can be negative 2/3. So now we need two values for x. And this is it. Can anyone solve this for x and solve this for x for us? What is the first x, please? Anyone?
2.
So when I move, yes, correct. So I move 1 to the other side, becomes negative 2. I divide by negative 1. I completely agree with 2. Perfect. From here, so we have negative x, and I have negative 2/3 minus 1, which will be negative 5/3. So the other one is 5/3. So again, you can say, wait a minute, couldn't I have just square this and then distribute 5? And yes, of course, you can. But we're trying to illustrate how useful this method is, because in other situations you will not be able to square them and distribute 5. So this is the method of substitution. But only if the equation is quadratic in form. If it can be substituted for a short while, if it can be substituted by a quadratic equation. Otherwise, the method is not applicable. Okay, let's look at another equation with taking square roots. So that's my page 5. So on the handout we have this 2x plus 3 squared. Sorry, this is problem 31. Minus 32 equals 0. So the same thing, we want to solve and find the x-intercepts or the zeros. And the problem is asking us to find the zeros using the method of our choice, but they are really telling us to use taking square roots. You cannot take square roots from a difference or a sum. So let me refresh your memory. The square root of a times b, assuming both are positive, you can write it as this in this form. It can also work for a ratio, assuming everything is positive. But it will never work for addition and subtraction. What am I talking about? The square root of a plus b does not equal the square root of a plus the square root of b. This is a huge mistake, and it's very tempting. So if I want to solve this equation by taking square roots, what do I have to do first? Before I even think of the method of taking square roots, which we just used a minute ago.
Two on both sides.
Say it again.
Got 32 on both sides.
Correct. Excellent. So I'm moving a negative 32 to the other side, so I have 2x plus 3, everything squared equals 32. Only now I can take the square root from both sides. Excellent. So the left-hand side should correct. So one more thing here. The square root of x squared does not equal x. No, it does not. It equals the absolute value of x. So I should correctly write the intermediate step here. The absolute value of 2x plus 3 is the square root of 32. And I will take the square root and simplify this in a minute. So is there a perfect square in 32? Is there, as a product, of course, as factors, is there something times something else that I could replace 32 by? Anything.
16 and 2.
16 and 2 is the best. Absolutely. Indeed, 16 times 2. Thank you, Axel. Good. Now, we like to skip this step, but this is the correct intermediate step. And what happens with the absolute value of x? Well, we know that the absolute value of x, anyone remembers the formal definition of the absolute value of x? And we'll come back to this. And I'll show you the shortcut. We omit this step, but this is the correct step from here to the next one that I'm going to write in a second. Anyone remembers what is the absolute value of x? The formal definition. We need it for later in the next handout, the next section. So there are two options. Anyone remembers what the options are? It's okay if you're wrong. Anyone?
Positive and negative x.
Good. Excellent. Thank you, Charles. Okay. If what? Because this is important. It goes with this and it goes with this. Without this piece, it's not enough.
If x is positive.
Or 0, correct. And of course, what else is left? If x is?
Less than 0.
That's it. So please keep this in mind. We're going to talk about it later. I just wanted to refresh your memory on this. Perfect. So then the 2x plus 3 should be positive and negative, this number. So the positive and negative do not come from this side. I don't want my students ever to say that the square root of 4, for example, is plus or minus 2. This is incorrect. It's not true. The square root of 4 is only 2. So the plus or minus come from the absolute value. Plus and minus. From this side, not from this side. And of course the square root of 16 is 4, and then the square root of 2 stays as the square root of 2. Yes, we like to omit this step, but I want you to understand where it's coming from. So from here, in order to solve using taking square roots, from here we like to write this immediately, skipping the intermediate step, but this is the correct step. And please don't say that the square root of 32 is plus or minus 4 the square root of 2. That will not ever happen. Again, the plus or minus come from this side. Okay, perfect. Now what do I do to solve for x? What is the next step? Anyone, please help.
Subtract 3.
Exactly. 2x equals negative 3 plus or minus 4 the square root of 2. Final step. Thank you. Was it Kevin?
Yes.
Thank you, Kevin. Okay, next step. Final step. Anyone, please?
Divide by 2.
Of course. I prefer dividing term by term. It's not incorrect if you write fraction line and 2 in the denominator. I prefer dividing 2x by 2. I prefer dividing negative 3 by 2, plus or minus. And when I divide 4 the square root of 2 by 2, I already simplify into 2 the square root of 2. Is it incorrect if you just write it over 2? No. But what it will be incorrect is this. And I've seen it many times. Students simplify this 2 with this 4. Please do not do that. If you leave it alone, it's okay. But if you start simplifying a piece of a term with a factor in the denominator, then that would be incorrect. Any questions on this method? Any questions on this method? Okay, finally, let's look at one more method. So what we had so far, we looked at solving equations by factoring, solving equations by substitution. We had taking square roots. Now let's review the quadratic formula and move on from here. I wanted to also show which equation, let's say this equation, it doesn't matter. Let me show you with the graphing calculator. I did show you last time, let's show it again. So this was what we did last time. So let's do it again quickly. So from scratch, you click on apps, you go all the way to polynomial number 9. Okay, so click on 9 directly. And it's a polynomial root finder. Click on that. And in this case, the polynomial is degree 2. They call it order, but we know what that means. So it's degree 2. Press enter. Make sure that you enter the coefficients in the correct order. In our case, the first coefficient was 3. The second coefficient was 5. And the last coefficient was 2, or the free term we call it. So the leading coefficient, the middle coefficient, and the free term. And we have them in the correct order. All we have to do is click on graph, and we get what we obtained, negative 2/3 and negative 1. But of course, this is not x, but it's y, so we had to solve for x afterwards. Any questions on this method? We illustrated this last time as well. Any questions? Anyone? Okay then. So let's review the quadratic formula. Okay, I'm on my page 6. So which method is this? This is number 4. So quadratic formula. And remember, the quadratic formula requires the equation to be presented in the standard form and correct in descending order, etc., etc., etc.